Welcome back. In today's video, we have a circuit that is constructed using the inverting amplifier topology. But in this case, we want to tie V plus terminal to the V out terminal by a resistor R3 rather than tying V plus to ground. So instead of having V plus tied to ground, we want to tie the V plus terminal to the V out terminal via a resistor R3. Then find the expression for the resulting output voltage, and in this case we're still assuming that the amplifier operates in the linear region, the ideal case. So let's go ahead, change the topology, and here we have R3, and then we can go ahead now and find the output voltage. So in this case, we know that if it operates in the linear region, by virtual short, we can assign the voltage at V plus to the voltage at V minus. And in this case, what is the voltage at V plus? We know that I plus is equal to I minus, which is equal to 0 amp. No current can flow into the V plus or V minus terminal, so I minus and I plus is equal to 0 ampere. If no current flows, the resistor R3 does not develop a voltage drop across by the current, so thus we know that the voltage across the resistor R3 is going to equal to V out. So we know that V plus is equal to V minus, which is equal to V out. By knowing this, we can then go ahead and find the voltage, well, not the voltage, but the output voltage by using superposition. In this case, we can say that V minus is equal to, by superposition, if we ground V in, so if we put V in source to 0, we can then, by voltage division, we can then say the voltage across R1 is R1 plus R1 divided plus R1 divided by R1 plus R2 with reference to V out. And then we can add the second part of that voltage division when we set V out to 0. So by setting V out to 0, we can then take the voltage across R2 with reference to V in, and that is by voltage division R2 divided by R, we can just say R1 plus R2 times V in. We then move forward and say that V minus is equal to V0. We can then bring this portion of the equation over to the left, which we get V out. In parentheses, we have 1. Just factor out V out, so we get 1 minus R1 in this case, divided by R1 plus R2 is equal to V in R2, R1 plus R2. We can then go ahead. We could multiply by R1. We can multiply by R1 plus R2. Cancel out. So thus, if we do that, we then cancel this out, cancel this out. So now we have V in times R2 divided by R1 plus R1 plus R2, R1 plus R2, and in this case minus R1. We see that R1 goes away, R2 divides out, thus we see that V out is equal to V in, and here we still have a voltage follower. So for this problem, the voltage at V in, the voltage at V out will equal to the voltage at V in if we set the V plus terminal to the output voltage. And in the other video, which will be to the right of your screen, we had set V plus equal to the voltage at V in, and we get the same thing as V out is equal to V in. And then we see if we set V plus to V out, we then still get that V out is equal to V in, which is a voltage follower. So that's it for this problem, and see you in the next video. Bye.